Good morning, everyone. Before we dive into our first lesson on limit, I would like to give you a general sense of derivative. For example, let's think there is function like this, y equal fx. Let's pick one point and x coordinate is a. So y coordinate become fa, isn't it? Because y equal fx. Let's pick another point, second point here, and x coordinates instead of b, I would say a plus delta x, because delta x meaning change in x. Let's say we move first point to the right side, amount of delta x. We have learned about average rate of change of these 2 points. Average rate of change is delta y over delta x. Delta meaning change in y. So from here to here, change in y. So I would say this much distance, delta y. Okay, second point of y coordinate is f a plus delta x, because here we put it into x. Okay, so average rate of change definition is delta y over delta x. To be more specific, delta y is same distance over here, right? So we can also say f plus delta x minus fa over delta x. Now we can imagine, what if this delta x become infinitely smaller or approaching 0? This is not exactly 0, but it means the second point getting closer and closer to the first point. People start wondering what would happen. This idea of delta x approach 0 is the first concept we are going to learn, limit. So once delta x approach 0, what would be this value? fa plus delta x minus fa over delta x. We define this value is f prime a. In other words, we called the derivative when x equal a. Okay, this is it. To summarize, f prime a meaning limit. Instead of delta x, I'm going to use h. We mostly use h. H approach 0, f a plus h minus fa over h. This is definition of f prime a. Lastly, let me explain this geometrically. Okay, what is the meaning of average rate of change geometrically? Geometrically, this meaning is slope of 2 points, first and second point, right? So this meaning slope geometrically. And then what is f prime a geometrically? F prime a is geometrically is slope of tangent line at the first point. Okay, slope of tangent line at the first point. Okay? Bye bye.